Now we're solving problem number 8, which has a right circular cylinder involved. So the first thing I'm going to do, of course, is draw us a right circular cylinder. And every cylinder has a radius r and a height h. Now this problem is asking us to find a can with the largest volume. And the volume of any right circular cylinder is pi r squared h. But it also gives us information about cost. So that's what we have to work with now and set up a cost equation. It says it's 2 cents per square inch for the top and the bottom. So we do 0.02 for the top and the bottom. Well, the top and the bottom are just simply two circles. So we do the area of two circles. Plus, it's 1 cent for the side, materials for the side. So we do 0.01 times the area of the side, which is 2 pi r h. Okay. Well, they also tell us that that's equal to 3 pi in the problem. Okay, that the cost can't be any more than a value of 3 pi. So we can simplify this and we get 3 pi equals 0.04 pi r squared plus 0.02 pi r h. Well, obviously we're going to have to solve this for h to substitute it into the volume expression. So I'm going to do that, and that gives me, I'm going to just quickly do some rearranging here. 0.02 pi r h then would equal 3 pi minus 0.04 pi r squared. Now notice a pi in every expression. I'm going to cross those out because we can divide those out. And that gives me 0.02 RH is equal to 3 minus 0.04 r squared. And then I'm going to divide by these to give me a final expression for H equaling 3 minus 0.04 r squared over 0.02 r as my expression. Okay, well now I'm going to substitute it into volume, and that gives me pi r squared times that big expression, which looks like this, and we'll need to simplify this, of course. Well, if you take a look, that goes away. Okay, and then I distribute, and I get volume equals, and I'm going to bring the 0.02 under the pi just to make my life easier, and that gives me 3r minus 0.04 r cubed. Taking the derivative, I get pi over 0.02 times 3 minus 0.12 r squared. If I set that equal to 0 and solve for r, I actually get r equals 25. Okay? I mean r squared equals 25, or r equals 5. Okay? Well, maximizing that very quickly, or minimizing this, is it maximizing or minimize? Largest. So if we do that, we get a plus here if we do it correctly, and a minus here by plugging in. So we do have a max. Now, in order to find h, I need to come back up and plug into this expression to find h. And in doing so, I get h equals 20. Okay, and that would be inches for both of these dimensions. And those are the dimensions of the largest can that can be built within those constraints.